So let's get started today with a DevOps overview. Let's understand like what is DevOps, why DevOps came in, and like how to implement this, and what are all the factors to consider to implement the DevOps strategy. Let's try to understand this in more detail. Let's get into the topics. Today we'll talk about getting clarity on what is DevOps, a big picture of DevOps, roles and responsibilities of a DevOps engineer, DevOps pipeline, and the DevOps tools and skills. Right. So when you look into DevOps, like we can see that like it's a combination of two teams, dev team and ops team. Right. So what exactly it is, how DevOps came in, let's have a deep dive into this. Let's understand the basics. Like for any application, for any product, right, to release into the market and for end users to use it, it might have gone through different process, right? And I mean, it might have gone through different process. Multiple teams might be working at the back end. The most important of those teams are development team, QA team, and ops team. Okay, let's talk about the roles of these teams. Like development team, you know that these people write the code, develop the application, right? They are responsible for building the application, right? They are responsible for delivering the application. And QA team, they would be testing the application, right? See that whether the client expectations are met or not. And operations is all about infra management, right? They would be taking care of the servers, services, access, logins, all of this would be taken care by this ops teams. These are the major tasks done by these three teams on high level, right? They would be also working with the network connections, all of these things. So in short, infra management is taken care by ops team. I'm talking about the traditional approach, right? So whenever developers are ready with the code, testers would be testing it. Once the testing is successful, once it meets the client expectations, they'll hand over the application to ops teams and dev team and ops team. If they need any infra for their task, let's say they want to test their application, they may need some new operating system, they may need some new service. So whatever requests they have, whatever requirements they have regarding the infra, they would be requesting the ops teams and ops teams would serve the request. Right here, I'm clubbing both this dev and QA together, and I would like to refer this as dev team. Right? When I say dev team, yes, QA also included. Let me call this as dev team because they work closely. Okay, I just want to put them together. So if they need any request, they would, if they need any requirement, if they need any servers or services, they would request the ops teams and ops teams will serve the request of dev team. During this time, right, ops teams are like, they are checking, they will do multiple checks because if something goes wrong, they should be able to bring it back. So before they serve the request of dev team, this is the request of dev team to bring up a new service or to install a new service. So ops teams, before they serve their request, they'll check lot many things like whether the servers would be up and running if they made this change. Are any services going to be impacted? Any networks going to be disconnected? They would do lot of checks before they serve the request. Meanwhile, dev team are still waiting for the change they need, right? They are still waiting. Ops teams are taking some time because they need to do all the checks before they serve the request. So now dev team thinks that ops team is taking too much time to serve the request. And ops teams think that developers would always request for something which they are not sure of. Because if you look closely, developers will be always looking for agility in the infrastructure. They need some changes to execute their tasks like test development and testing. Ops teams will be always looking for stability in the infrastructure. What may happen, infra should be stable, the server services should be up and running, right? That's what they would be checking. So there arises some gap between these teams. There is some gap between these teams, like because they don't know why developers are asking those requests, and developers doesn't know why they take so much time to serve their requests. So there arises some gap between them, right? How to overcome this gap? There is a gap because there is no proper understanding, no proper communication, and their core skill sets, their core competencies are different, right? Developers would be knowing some programming languages, some DB, some build tools and all. Ops team's core competencies are different, right? They would be working on admin part, configurations, and so on. So their skill set is different, their core competencies are different. Each doesn't understand the challenges of others. They are working in silos and there's a gap between the teams. How to eliminate this gap? How can we eliminate this gap and how can we make these teams work together in proper collaboration? How is this possible? Anything, any input from your end? What do you think? How can we eliminate the gap between them? That's where DevOps came in. I'm talking about the reasons why DevOps came in. First reason, to eliminate the gap between them. What is the second reason? Second reason is, like let's assume, okay, developers are ready with the code. Okay, development team will hand over their code to QA team. QA team will test it. If they find any bugs, again, they'll send it to dev team. This process keep on continuing. Let's say the application is defect free. Then it would be handed over to ops team, right? In the traditional approach, that would be handed in the form of an artifact, like a var file or a jar file, let's say. And ops teams, once they receive their application, they have to do a lot of things. They have to set up the infrastructure. They have to see the infrastructure. I mean, the infrastructure setup, the softwares are compatible, right? They have to see they are installing the right versions of the software. They have to see they are configuring the right versions of the operating systems, right distributions of the operating system if it is Linux. So they have to do a lot of checks. And the dev team, when they are handing this artifactory, they'll also hand over the instrument documentation. Right, they'll also hand over the instructions document. This instruction document is nothing but a document which will have all the configurations. Like let's suppose they were handing over a Java application. Which version of Java need to be installed on all the servers, right? Which kind of operating system they would need. All of these instructions they'll provide. Ops teams can follow those instructions and set up the infra and deploy the application, means run the application so that end users can use it. But there would be a lot of challenges following this instruction document. The instruction document handed over by dev team may not be understood by ops team, or else some of the instructions may not be working. Some of the instructions might be working on, let's suppose, Windows, but may not be working on Linux. So ops teams have to figure out all of this and they have to run the application. Also, they have to look for stability of the application or high availability of the application. If something is broken, they need to be bringing it back in very less time. So all of these things ops teams should take care of. Definitely it takes some months to deploy, where deployment is becoming slow, right? So that's again another reason why DevOps came in, to faster the deployments, to increase the pace of deployments, to increase the velocity of deployments. So with the DevOps, okay, I'll talk about it later. So to eliminate the gap, to make the deployments faster, and what else? Before we talk about the third reason, let me just give you a simple hint at this point. Earlier, they used to share that var file and ops teams have to struggle with underlying versions, underlying operating systems, and they have to set up the infra, set up the environment. But now, with DevOps came in, the dev team is not handing over the artifact directly. They were handing over the artifact in the form of container image. Means they were containerizing the application with the Docker and handing it over. So if it was handed over in the form of a container, they need not struggle with the underlying dependencies. Ops teams need not work on the underlying dependencies. That container image comes along with all the dependencies. So it works seamlessly in any environment. Anyway, we have a separate dedicated chapter on this. So don't worry. Just I have given you a hint. Just understand the way of development, the way of deployment changed with Docker, which led to faster deployments, right? Also automation came in. That's where like you have Docker, which containerize the application, which can help you pack your application along with the dependencies. But let's keep that container topic aside. Let's talk about the reasons. One is to eliminate the gap. Second one is the faster deployments. Shall we go for the third reason? Is this much clear for all? Everyone following and with me? Good to go. A quick thumbs up will help me. Okay, let's talk about the third reason. Like due to the software traditional methodologies. Yes, I'm talking about software development lifecycle. Right? This is the traditional methodology which served the industry for decades. Right? But there were challenges which it has faced, like which it has posed for both the dev team and ops team. Software development lifecycle. Let me give you a brief of it for anyone new here. Software development lifecycle is nothing but sequence of activities involved in development, like requirement gathering, right? Then comes requirement analysis, design, coding, testing, and delivery. So these are the different stages. Each stage goes one by one, like one after the other. Once requirement gathering is done, analysis, then design, coding, delivery. So it goes in this direction from top to bottom. You cannot go back. Like let's suppose you are in coding, you cannot go back for requirement analysis. And hence the name waterfall. Yes, I'm talking about the typical waterfall methodology which served the industry for decades. Though it served the industry for decades, it has got lot many challenges. Like a dev team used to face lot many challenges because this methodology is very slow. Let's suppose coding is completed now. It would go for testing only after some months, right? It wouldn't be immediately going for testing. It will go for testing only after some months. Meanwhile, developers will be working on the old code. And bugs will be coming in the new code. Developers have to fix the bugs in the old code and work on the new code, which would be definitely challenging. So this methodology is very slow and like it's not flexible. Like let's suppose you are in the like coding phase. Developers are writing the code. Let's say client came up with new requirements and modifications to the requirements. It's not possible. It's not allowed. Right? If the model is not flexible, it doesn't work in reality because nowadays clients keep on coming up with the new requirements, modifications. But if that cannot be handled, it doesn't work in any way. Like waterfall methodology, let's say you will get the requirements in 2025. The requirements will be freezed and the product will be delivered after some couple of years, like 27. In these 2 years, no modifications, no new requirements would be taken. Requirements will be freezed. If that is the case, definitely that would be a challenge, right? It doesn't work in reality because nowadays it's a business changes rapidly. It's a customer facing world. So if they don't accommodate that, it doesn't work. That's why this model is not flexible and complete software is delivered all at once after 2 years without accepting any changes. Client doesn't need the product anymore, right? So these are the challenges faced by dev team. Similarly, ops team also face challenges because of the waterfall methodology. This methodology is very slow. So they have to maintain server uptime for longer duration manually is a challenge, right? And poor configuration management. Again, configuration management is a separate concept which will be handled by tools like Ansible. Here, let me give you configuration management means having a detailed history of what changes are happening on what server, right? That kind of concept is called configuration management. Also, you will have a better control on the infra, which is done through Ansible. So, poor configuration management and also no automation in monitoring, poor monitoring. If there is a small infrastructure, you may monitor them manually. But if it is huge infrastructure, you need some good monitoring tools, right? But all of this is manual in the traditional approach. So this methodology has got lot many challenges. And again, how do you overcome these drawbacks or challenges? Actually, to overcome this, Agile methodology came in. Another methodology called Agile. Here, intention is not to teach you waterfall or Agile, but just some understanding and the history, how DevOps evolved, right? So, Agile methodology was there. This was successful. So, it can overcome challenges of dev team. But challenges of ops team are still there. Challenges of ops team are still there. That's where DevOps came in actually. which can overcome challenges of both the teams. That is what is DevOps. But before we talk about DevOps, Agile was successful to this extent. How it was successful? It was successful because it implements a concept called continuous development, continuous testing, continuous integration. What does it mean? Let's talk about week one. Here code will be developed in bits and parts. A chunk of code A is developed on week one. Immediately on week two, this chunk of code A will be going for testing. It's not that testing will happen after 6 months. Immediately next week, testing will be done. Meanwhile, developers are not sitting idle. They are developing again another chunk of code B. Again on week 3, this B will be tested. Correct? Also, at some point of time, A plus B will be tested. Means that is new changes are merged into the system and tested. Then only it makes complete product, right? This is called continuous integration. If you see every week, development and testing both are happening parallelly, iteratively, continuously. Not that after complete development coding, after complete coding testing is begin, testing and development are happening parallelly, iteratively. That is what is called continuous development. And any new changes developed will be merged into the system and tested, which is called continuous integration. Right? Because of this, it could eliminate the challenges of development team. But challenges of ops team were still there. Is that making sense, everyone? We will deep dive into this continuous development testing process, how it works in the CI/CD pipeline. But is this much clear an overview? Got an idea, everyone? Can I proceed? So this is what Agile does, but it was successful to a certain extent. But then DevOps came in, through which you have continuous development, continuous testing, continuous integration, continuous deployment, and continuous monitoring as well. Right? Let me try to differentiate these three methodologies. Let's talk about Waterfall, Agile, and DevOps. Right? In Waterfall, you have development. After that, you have testing, and after that, you have deployment and monitoring, one after the other. Right? But in Agile, you have development and testing happening parallelly or iteratively. But then deployment is manual, and once after complete integration is done, it would be deployed and monitored. But now with the DevOps, continuous development, continuous testing, continuous integration, continuous deployment, and continuous monitoring. Got it now, everyone? That is the difference between the three methodologies. If you want me to differentiate this with respect to the teams, like in Waterfall, you have development team, QA team, ops team working in silos, means working in separation, in isolation. Each team doesn't understand, doesn't interact much, doesn't understand the challenges of others. Whereas in Agile, these two teams, because development testing happening parallelly, these two teams were brought together, means they were working in proper collaboration. That's all. Brought together doesn't mean that developer is going to write the code, but they were brought together, and hence I am just referring them as dev team. But ops team is still left in isolation, right? Again, with the DevOps, these two were brought together, means these three teams are working with the proper collaboration, with proper communication, constant interaction by understanding the challenges of others. So they work like a single team that establishes the proper collaboration. Is that making sense, everyone? So this is what is DevOps. Also, in practical, if you want me to explain, okay, what exactly it is, okay, we understood they are working together. What exactly it is, what is the task of a developer from the desk of a developer? Like once the coding is done, completed by developer, it should reach the production table automatically. So how it will reach the production table automatically without manual intervention? All this process is nothing but DevOps. The process of taking the code automatically to production table is nothing but DevOps. So what is the process involved here? Yes, there are many processes, like a lot of things involved here. CI/CD particularly, continuous integration, continuous delivery pipelines are created, right? Also, the infrastructure management is automated, configuration management, continuous monitoring. All these strategies are implemented. So how is this possible? Through automation. Automation 24/7 possible, right? With the use of tools and strategies. So this is what is DevOps. When you talk about what is DevOps, generally huge tool stack, definitely huge tool stack comes into mind. But DevOps means just not blindly implementing the tools and the strategies. It's all about taking a decision of how can you create your deployments more efficient and reliable. The solutions, the pipelines created should be efficient, should be reliable, right? Initially, to create a pipeline, you may need some, let's say, 10 people. But once the pipeline is created, you need 1 or 2 people to monitor it, right? So it's all automated. Initially, you need more people. Now you need just 1 or 2 to monitor it. This is one part of the DevOps, CI/CD. There are also other aspects. It's not just CI/CD. What do other 8 people do? They work on infra management. Infrastructure management should be done. Infrastructure should be created, deployed. Should be created, replicated, modified. All of that should be taken care, which is done through Terraform. The same infrastructure should be configured with Ansible. An entire environment can be monitored with some monitoring tools like Prometheus. These are also other tasks apart from CI/CD, right? So these are all the things which DevOps engineer would be focusing on. And when you are automating the whole thing, that's what companies need, right? They need the products delivered very quickly at the faster rate. Right, they don't want the delayed deployments after 1 year or 2 year. Have you ever wondered, like if you take the gigantic applications like Amazon or a Facebook or a Netflix, a feature would be released immediately in a day, right? How is that possible with the DevOps? Facebook is a best example which implements DevOps. So how it is possible? How can you release the new features in a minutes or hours? How is that possible? Through DevOps. So companies need faster deployments, right? Features should reach the end users effectively, efficiently, with the faster rates, with the less people. So everything is automated, no manual errors. That's what companies need. Almost all the companies are stepping into it. In couple of years, everyone will step into DevOps. DevOps is what is it's actually a methodology. It's not a tool. It's not a just a technology, or it's not a programming language. It's a methodology. It's a process. In this process, there is automation of 24/7 where we use different tools. But when we talk about what is DevOps, it's a methodology, right? So it takes time to implement this methodology, to own this methodology. We just hear that, okay, we are implementing DevOps from today, our project is complete DevOps. It's not an end process. It's never ending process. Means it's a continuous ongoing journey. You'll be keep on improvising your pipelines, modifying your pipelines. You keep on working on making the pipelines optimized, right? So it's a continuous process. It's a continuous journey. You can't say, okay, our project is complete. It's a DevOps project. We have implemented it thoroughly. No, it's a continuous process. People should own this culture of working like a single team without blaming each other, with a proper understanding and proper collaboration. When I say that, I want to remove the misconception. When I say they're working on same team, doesn't mean that DevOps people will go and write the code or do the testing. No, they are all separate teams which work together. So whoever want to own this methodology, whoever want to master this methodology, right, can become a DevOps engineer. So if you are a developer, if you still want to continue as a developer, still you have to learn it, because some time back I have given you a hint, right? The way you hand over the application changed. Developers are handing over the application now in the form of containers. So obviously they should know like how containers work, how to containerize their own application. So that's how developers should learn it. Or else if they want to move to DevOps, yes, they have to completely learn this automation process, right? They should have an idea of it. Even though they don't want to migrate, they don't want to switch, still they need to understand, because this is the pipeline their code would be passing through. If something is blocked, something is gone wrong, like they need to have a look at it if it's from the perspective of developers. So developers should learn it. Same is the case with the testers and everyone. Is this much clear? I think I made the things clear about why DevOps came in. We were talking about why. Why do we need DevOps? Is this clear to all now? Is this much clear? Appreciate your quick responses, or if you would like to share anything from your end, feel free to raise your hand. Good to go. All right. Thank you all for confirming. So now that we understood DevOps and what is DevOps, I have explained you what is DevOps as well, right? Like the continuous development, continuous testing, continuous integration. So this is what is DevOps. Now, how to implement DevOps? That's where the hands-on comes in. DevOps is completely hands-on. Just listening the theory or just reading the documents wouldn't work. You have to do the hands-on completely, right? That's where the how part implementation comes in, which will start from the next day. Like tomorrow onwards, we'll get started with this hands-on part. Let me see here. This is the presentation. Even this presentation is also available in your LMS, the learning management system, which you have got access to. And this shows everything, whatever we have discussed till now, like requirement gathering, requirement analysis, design, coding, testing, delivery, and the drawbacks of waterfall methodology. Like it's a slow process. Requirements cannot be changed. Servers uptime, infrastructure tools were not enough to manage huge number of servers, difficult to identify the bugs and fix them in the waterfall methodology because developers have a lot of stress, lot of pressure on working on the old code for bugs and work on new code for the new requirements. So that's a challenge of a waterfall methodology. Then came Agile. Agile code is delivered in short deployments like sprints. Like it's not code is all developed at once. It will be developed in chunks, in bits and parts in the sprints, right? Every week there might be a release. So development and deployment process became faster. Requirements can be changed and could not bring agileness to operations. Hence overcomes the problems of development process but not operations. So that's where came DevOps. Overcome the drawbacks of traditional software development lifecycle. It allows collaboration between development and operations and it will automate the complete workflow. Right? So what is DevOps? It's a software development approach. It's a methodology which involves continuous development, continuous testing, continuous integration, continuous deployment, and continuous monitoring, which is called DevOps. And yeah, this is what I have explained some time back, a comparison between different methodologies like waterfall methodology, Agile with continuous deployment. Right? If you see design, after design coding starts, after coding testing and then deployment. But now with Agile, you have design, coding, testing. This happens iteratively, right? But deployment is all manual. But in DevOps, Agile with continuous deployment is called DevOps. See here, design, coding, testing, all of these are happening iteratively. Means any code change done by developers, any new feature developed by developers will be released immediately on the same day. End users can see the feature on the same day itself. Right? Means whenever developer make a change, it would be released to production automatically. Of course, first it will be deployed to lower environments, then to the higher environments, which is called DevOps. Any questions from anyone in this part? And then the roles and responsibilities of a DevOps engineer, like I discussed in the demo, but let me give clarity here. So roles are like the pipeline management, CI/CD pipeline. You might be working in any stage in the pipeline, like you might be working in the build phase or in the test phase. Like testers will give you the test cases. You are automating the test case execution in the pipeline. So if some tests are broken, that would be again sent to developers, like notifications can be triggered, right? can be included. The reviews can also be automated in the pipeline. Okay, let me just give you a hint on the pipelines. Okay, developers write the code that would be passed on. So continuous builds, continuous development, continuous builds, continuous testing, continuous integration, continuous deployment, and continuous monitoring, right? So here in the continuous builds, you may also have a code reviews implemented in the pipeline itself. You may also have the coverage done, coverage analysis, static coverage analysis included, code scans may be included, right? Image scans can be included in the pipeline. So these are all the different aspects. These are not mandatory. It depends on how they design the pipeline, right? So these are all the different stages that could be integrated into the pipeline, like deployments, continuous deployments, like deploying onto lower environment than to higher environment, or else infrastructure provisioning can be included. Infra provisioning with Terraform can be automated in the pipeline. Okay. Also, Ansible could be configuring the infrastructure in the pipeline. These are all the different stages that could be integrated. And again, I want to tell you, it's not mandatory that your pipeline should have all these stages, and it's mandatory should to have. It depends on how they design their project, how they design their application, like how they design the delivery process. But these are all the things that can be integrated. And also deployment to, it could be deployment to any instance. Let's say an EC2 service, we'll learn what is EC2 and all, or else it could be deployment to an Kubernetes cluster. And infrastructure, either it is EC2 or Kubernetes, can be created by Terraform and configured by Ansible. These could be the different tasks that can be integrated. Right? These are all the different tasks. So as a DevOps engineer, you might be you might be asked to work, you might be assigned with a task to work on any stages as such. Right? Also, like I told you, DevOps teams will have the sprints. Any task coming up their way will be planned and prioritized and will be handled in each sprint respectively. And if you're working in a DevOps support, yes, you will have a continuous support tickets, like it could be a Jira ticket or a Snow ticket where you need to work on. It could be a non-prod issue or it could be a prod issue which should be looked in on priority. Is that making sense? So you might be working in a core DevOps team where you will create, see, it might be about fixing those stages or troubleshooting, or it might be creating a pipeline from the scratch if you are in a core DevOps team, or creating the infra with the Terraform and configure it with Ansible, right? These are all the different tasks. Configure the infrastructure. Here I'm writing the task in general. We'll go to the specific tasks as well once we start our hands-on. Hope this much is clear for every one of you. Right? These are some of the roles and responsibilities of a DevOps engineer. We'll pinpoint to them once we get started with the hands-on. There is a question from Pranchal. Can we get these documents? Yes, Pranchal, you can get all the documents, whichever I'm using. The presentations are also available. I believe by now you all got access to your LMS, right? Have you all got access to your LMS? So just go to your LMS. As it is a beginning initial days, let me show you where you can find this. Like if you go to the live classes. So this is where you have the LMS trial access, right? You might be having an actual access now. So go to your LMS access, go to My Learnings. Once you go to My Learnings, you will see your program here. Go to View Program. Okay, here you should see something like Lab Notes, right? Lab Notes is the one. If you go to Lab Notes, here the course is categorized into modules. Okay, go to module 0, the first module we are covering as of now. So this is where you have all this presentation available. Okay, this is where it is. Hope everyone is clear with the navigation and where you see the content and everything. Whoever still doesn't get access to your LMS, please check your email. You should be receiving the access by now. Okay, so the skills and tools of a DevOps person, like, see, these are all the different tools we have, like version control systems, build automation tools, continuous integration, containerization tools, infrastructure as a code and container orchestrator tools, continuous monitoring and cloud computing services. So these are all the gist of the tools. Here I have listed only the brief list of the tools. You can go to the website for the course content for the syllabus. Here it is. Here is the syllabus. If anyone haven't visited that, okay, so here is the course content. Under syllabus, you can see the course content which we are going through. As of now, I'm going through this part. Right in the initial demo, we have covered a few major differences and the buzzwords and the frequently asked questions. And today we were trying to elaborate the differences between, why DevOps came in, what exactly it is, who are eligible, the roles, responsibilities, and so on. Right? Okay, so these are the tools we'll be covering. Along with this, we'll be covering Linux basics as well. Linux basics are needed. It is navigating to the files and folders is required, which we'll be covering from the basics. So this is also covered in this course. Prabhu, please, can you ping Mr. Raj for the access? If you are not seeing your LMS, please ping Mr. Raj. And by the way, have you enrolled the course? If you have enrolled, you should be receiving it. Please ping Mr. Raj. Okay, so that's a Linux access. Linux basics will be covered here, and also this one of the reason for it is majority of the DevOps tools. Like for example, if you take Docker, Docker works on multiple operating systems, but still you need the Linux operating system. Means it's natively developed for Linux. So we need Linux. Here's even Prometheus, Ansible needs Linux server. So that's one thing, and also Linux is more secure and more widely used. So Linux basics will be covered and also AWS will be covered. AWS services relevant to DevOps will be covered. So this is the brief course content. Any questions from anyone on this page? Any confusions, anything? What is each tool does? What are their role? What is their architecture? We'll go deep dive into each components as we progress. Any questions in this page from anyone? Okay, moving on. So this is the CI/CD pipeline I'm talking about in the day one or till now we were talking about this, right? So if you see here, developers will write the code, publish their code on GitHub, right? Once code is placed on GitHub, we will create a pipeline in such a way that whenever developer make a change, make a code change, the pipeline will be triggered. It will do the continuous builds. We're using some build automation tool like Maven, Maven, and so on. It will do the builds, and once builds are successful, testers will be writing some test cases, right? Those test cases will be automated here, which is called continuous testing. Those test cases may be written in Selenium or JUnit or UFT or whatever it is. It could be any test automation tool. Right, it is a choice of developers and testers who will take the call, and accordingly they'll write the automation test cases. Those test cases will be executed via this pipeline. Means test case execution is automated. which is called continuous testing, and then deploy to the production, of course, first to the lower environments, right, like a dev, staging, and then to production. Even that production environments will be created by Terraform and configured by Ansible, on which you will be deploying your application as a containerized applications, and you may be orchestrating them with Kubernetes. That's how different tools comes in. Let me write here what each tool does so that you'll get some idea. So developers will push the code to this is version controlling. Maintain the versions of the code. Okay. Jenkins is a continuous integration tool. CI tool. Maven is a build tool. Other tools are like Ant, Gradle, and so on. Okay, and Selenium or else UFT or a JMeter, it could be any test cases, right? And then it would be infrastructure will be created with the Terraform. You need an infrastructure to deploy an application, right? You may need an operating system, you may need a EC2 instances and all. So infrastructure need to be created. And that will be configured by Ansible. Means, okay, infra is created. Let's suppose a server is created. Is that much enough? You need to install the respective softwares on those, right? Like you may have to install Java, you may have to install the right version of Java, the right version of operating system and all. So the configurations will be done by Ansible, right? And your application is containerized. You are not just deploying the WAR file or the jar file, rather you are deploying it as a Docker container. So containerizing the application, and that containerized application will be deployed here. And those containers will be orchestrated by Kubernetes. This is Kubernetes. This is Docker. Right? So this is the continuous integration server, Jenkins. So how we will learn this? First, tomorrow onwards, we'll get started with the Git. We will learn the basics. We'll get started from the basics till advanced concepts, right? We will master Git thoroughly and get started creating this pipeline. And then we'll start with Jenkins. We will again start from basics till advanced. We'll learn the architecture, each and every concept of Jenkins, and we'll come back into add this into the pipeline. And then we will learn Maven, a build automation tool. This is actually a developer tool. So we will learn whatever extent we need as a DevOps engineer, and this doesn't need any coding. So we will learn this and come back and add it to the pipeline. That's how once test cases are provided by testers, how do you implement automation testing in a pipeline? So that's how each part we will zoom into each part and master it thoroughly. Got it clear, everyone? So where do you implement these pipelines? We can implement these pipelines on a cloud or else on any on-prem environment as well. So as a cloud example, we are covering it on AWS. And this pipeline creation will take some months. Like in our 2 months course, we'll be creating this pipeline step by step. Initially, it might be like, this is just an overview. You may not get a deep clarity on it. As we progress, right, you will be able to connect the dots and create these pipelines. We'll be creating these pipelines on multiple applications. Like I told you, we'll be creating it on a monolithic application and also a microservice application so that you get exposure to different scenarios and different types of setups. Any questions from anyone in this part? This is the high level picture of what we will be doing in our course and how we'll progress and what are the tasks a DevOps engineer would expect and all. Here, if you go to this notes, all the DevOps nodes. Let me take you to some thing like Docker. These documents will help you with all the scenarios, all the hands-on. Okay, let me take some Docker class 3. Right, you can see this is the 5th module, 3rd class, first exercise. Right, it's all about Docker volumes, creating a Docker volume. These are the commands, Docker exec, my container, ls logs, and also these documents will help you do your hands-on smoothly. Right, so this is how we have different exercises on this lab assignments. This is Jenkins data persistency with volumes, which is a real scenario. Like you have a Jenkins, which is a CA server, right? You need to take backup of it. How do you do that? We can also run Jenkins in a container, and data persistency or data backup can be taken with volumes. So those scenario-wise topics are here. Once you get started, you will understand to use these, like how to use this documentation. But now we are in the module 0, the first module wherein we are talking about the intro part. This is where we are. And by the way, I'm still having questions. I'm receiving questions from participants regarding the LMS. Let me show you this. See, once you log in, create a Gmail account. I mean, log in with a Gmail account. Create a free account on this website. And once you log in, you'll be going to My Learnings. Go to My Learnings. Once you go to My Learnings, you will see your program here. Like I'm seeing April program, you should be seeing the June program. Either it is a free trial or you are enrolled, you will be seeing it here. But it's a free trial, you'll have a limited access, right? So if you have enrolled, you will see the full access. Go to the view program. This is where you should be seeing the recording, class recordings of yesterday's and today's. Today's will be under the DevOps intro, right? And then the Git version control systems. Here are all the recordings that would be posted here. Check your LMS. Okay, at the bottom, you should see lab exercises, quiz, interview questions, everything you should be seeing here. Like each day, if you click here, Git 1, Git 2, you'll be seeing the recording and the relevant lab exercise, quiz, interview questions of the particular day. Hope you all got access to it, but still whoever haven't received the access or having a struggle receiving the access, this is where you should go. If you want to do all the hands-on at once, like you want to see all of those assignments together, this is where it is. These are the lab assignments. All right, day-wise you have, so that you can complete your hands-on day-to-day hands-on, you can complete, and that's how you can master it. By the time we complete the course, everyone should be comfortable and master the course by the time we complete it. Any questions from anyone? And I'm sharing the quiz for today. Quiz portal. You can see quiz for all the days. Let me share the quiz for today. It's a quiz for day 1. Just give me a second. I shared this quiz yesterday as well, like some of you, I mean, majority of you have completed, but whoever joining today, like we have people who joined today as their first class, so I'm sharing the quiz. Please go through it. Let me share a quiz once again. Can you all see the quiz? Can you all access that poll which I launched on the Zoom? If you haven't seen that, click on more. You should be able to see it. Yesterday, those questions might be new, but today we have covered some of the topics there. So feel free to take the quiz and the scores will be released in some time. Any more questions from anyone? Any questions? This is the theoretical part or the intro part, like the high level picture of what DevOps, why DevOps came in, why we should learn it and all. And this is the CI/CD pipeline, which will be starting from tomorrow. So that's a theory or the intro part of DevOps, which I covered today. Any questions from anyone in this part? Please let me know. Please, everyone, click on the more button and you should be able to see the quiz. If anyone cannot see it, please let me know. Can you all see the quiz available, launched on the Zoom? Any questions regarding the CI/CD part or anything you need clarity, please let me know. Can you all guys see the quiz? I see 80% of you on the quiz part, remaining 20%. If you don't know how to see the quiz or if you are missing that option, let me know. I can help you with it. Whoever joined today, particularly as a first day, of course, this is the first day of the course. If you haven't attended the previous demo, again, I have covered the content which I covered in the demo as well today. Still any more questions, let me know. Almost 85% have started their quiz. Reminding people, whoever cannot see, please click on more button on your Zoom window to see the options. Thank you, Sheikh, for submitting your quiz. How about others? If everyone is done, once everyone is done, I'll release the scores. Now 90% people started their quiz. Remaining 10% also, please see if you can see the option or any help needed, let me know. Every day after the class, this is how your learning should be. You should take up the quiz. Let's suppose tomorrow we are going to get started with the Git day one, right? So once we go to this day one, like once we complete this particular day one, yeah. Once you complete this day one, you should be taking up this quiz. This will help you register your learning, validate your learning, right? Also, you should be taking up going through these interview questions, which are on the topics covered on that particular day one of Git. right? Like the beginner level you can get started with. And the lab exercise of the particular day. These are the things which you should complete on a day-to-day basis. It's not that you pile up all of them and do it after some 15 days. No. Every day you should complete these three things. This is your homework or assignment. The lab exercises, quiz, interview questions should be completed relevant to the particular day. So day-to-day basis, you should be doing it till the end of the course. That means you need to maintain consistency. Your consistency, your effort, your dedication will help you reach your goal. If you have dedication, if you are ready to put the effort and some time for DevOps, we are here to help you reach your goals. Almost 97 people, 97% of the class are taking the quiz. Remaining people, whoever can't see, please check and hope everyone have got the LMS. Still any questions regarding the LMS access or anything, please reach out to this number, Mr. Raj. This is the number contact for Mr. Raj. He can help you with all the guidance you need. I see many people who joined today, who are everyone enrolled but joined today directly. So any help needed, please reach out to us. I'm seeing questions relevant to the LMS, relevant to the access. So I have answered almost everyone, like how to access and all. Still any help needed, please ping Mr. Raj on this number. Have you all completed the quiz? If completed, please let me know so that I'll release the scores. Every day this quiz activity will be there. I'll release the quiz as well. You can also take from your end. You should be getting used to going through the quiz on daily basis, the assignments and the lab exercises. That's how you get your understanding on day-to-day basis. I'm seeing questions relevant to DevOps and SRE. Okay, this part is covered in the demo class, right? In the demo, which is yesterday, I have covered this. Let me just take you through this. DevOps and SRE. See, DevOps and SRE are, like I would say, SRE is an extension of DevOps. See here, if you see SRE, I would define SRE as DevOps plus reliability and performance. Means DevOps, DevOps will be focusing on faster deployments, automating the deployments without any manual intervention, right? To speed up the deployments. That is the focus of DevOps. Whereas SRE is, yes, of course, it will also focus on the faster deployments, plus the reliability of the applications, reliability of your pipelines, and the performance of your applications is the major focus for SRE. SRE means site reliability engineering. Site reliability engineering here, site means anything relevant to your environment. It could be a website, it could be a your servers, it could be your infrastructure, it could be anything in the environment. It could be a database, anything is a considered as site. So site reliability, you would be working on setting up the reliability of your application, performance of your application. So SRE job role will be more of an on-call support, right? Also the support and incident management comes under SRE. Incident management meaning I told you yesterday, or else let me tell you, there were different types of projects. You might be working as a core DevOps engineer where you will create the pipelines, you will create the infrastructure, everything from scratch. Means for every DevOps development team, let's say there is a development team. Okay, there is a development team one. Okay, for every development team, there will be a DevOps team who will set up the pipelines, who will set up their infra, everything. Right. So this is where you will be. So you will be working on creating everything from scratch. There is another aspect of it. There will be different development teams who need the pipelines to deliver their code. Right. For all these development teams, there might be a DevOps support. A single team who will provide the support. Means here DevOps team will not create the pipelines, but once pipelines are created by their own, like by the respective development teams or like whatever teams they are, like once they create it, if something is broken, there'll be DevOps support, right? So that will be a non-prod. If let's suppose if it is a non-prod issue, there'll be a support raised from a Jira or something like that. But if it is a prod issue, they'll create an incident. Incident means which need to be addressed on priority, right? It could be an incident. Again, incidents will have different priorities and severities, and that's how they should be addressed. So, yeah, so that's an on-call support. You'll be getting an on-call, like you'll be getting a call regarding an incident. You should log in and address the issue. And if you need other teams involvement, you should engage the respective teams. Let's suppose infrastructure is management by a separate team. You should engage them if something is broken with respect to the infra. So that's how you will have it is a more an on-call kind of thing, the SRE, right? Where you will be working on performance, reliability. The system should be reliable, up, available always. That is what is SRE focuses on. Again, it's a DevOps. Yes, SRE should know all the DevOps tools, particularly the Kubernetes, the Terraform, and Ansible for configuration management and all, and the Jenkins to automate the whole process. Right? Also, if something is manual there, right? Okay, DevOps automated everything. It's a pipeline, CI/CD pipeline is there. But if something need to be automated there, let's say there is a task which is happening manually, and every day that task need to be done, and it is going on manually as of now, it will consume a lot of toil, right? It's a lot of toil for the teams. So how do you reduce the toil? That is another focus for SRE. Am I clear and understood, everyone? So that is the difference between DevOps and SRE. Whether it is SRE role or DevOps role, these terms are used interchangeably in the industry, right? They'll call it as SRE, they'll call it as a DevOps, but this is the strict difference between them. If you are interested into on-call kind of, if you came from support background, yes, you can go for SRE. Once you know DevOps, switching to SRE would be a little learning. With a little learning and exposure, you can switch to the SRE role. Hope that is clear. Whoever still having questions, please let me know. You can raise your hand so that I can unmute you if you have anything to talk, or you can use your Zoom chat, or you can also put it in the questionnaire. Yeah, almost everyone have submitted the quiz, and I'm releasing the scores. Can you see the results and the scores received, everyone? So the first question is, what is DevOps? The right answer is it's a methodology, a cultural change. Some of you answered as it's a combination of development and operations. It's not a combination of development and operations. It's a collaboration between development and operations. May I know who all have given this as a combination of development and operations? Just recheck. Okay, it's not a combination, it's a collaboration. So the right answer is it's a methodology, it's a cultural change. It cannot be achieved in an overnight, in a day or two. It's a continuous ongoing process of improvement and implementation. So who can be a DevOps engineer? So the right answer is all of the above. Developers can become a DevOps engineer, QA, Ops, or admin teams. All of them can become a DevOps engineer. So the right answer is all of those. Almost 89% of the people have given the right answers. And what DevOps is not? I think this is okay. What DevOps is not? Today I explained this. It's not a technology, it's not a tool, it's not a programming language, right? So the answer is all of the above. And the next question is, what is continuous integration? Again, the right answer is the process of continuous building, testing, and integration to the system is the right answer, and almost everyone have answered it correctly except few. 22% answered as rapidly, safely deploying code to prod environment. No, that's not a continuous integration. It's about continuous builds. Whenever developers write the code, that should be built, tested, and then deployed, which is called continuous integration. And the next question is, what is Git used for? Maintaining versions of the files. 100% answer this correctly. And then what is Docker? Used to deploy the application. Some of you answered, and the right answer is used for containerizing the application. We did not cover this yet, but just have given you to see like your awareness, but that's okay, whatever answer it is. It's about containerizing the application, which we'll be focusing on our module 5. And what is Terraform? It's the infrastructure provisioning tool. Again, 56% answer this correctly. It's a use for provisioning creating the infrastructure. And what is infrastructure as code? Looking at the infrastructure in the form of code is called infrastructure as a code concept. And which of these essential change that dev and ops must make to achieve success with DevOps? And the right answer is stop working in silos and work together is the right answer. DevOps is an extension of. The options are Waterfall, QA, Agile, or all of them. The right answer is all of them. Extension of Agile is the right answer. So that is about this. Can you all see your scores? I too can see the scores of each of you. Can you all see your own scores? Okay, that is great. Thank you all for confirming that you can see the scores. So that is about an understanding of DevOps and some important terms, terminology coined across DevOps. Hope the concepts and the things discussed were clear. Any more questions, please feel free to let me know. Okay, there's a question. Shrikant raised the hand. And Shrikant, you can unmute yourself now.
Hello, Preeti.
Yeah,
Hi.
hi.
So I'm watching from another country. It's late night, but I am just started. So let's see how it's going to be.
Thanks a lot for joining and spending your time for
Yeah, I don't live in India, but before in India, I work as a business analyst. So I want to be a DevOps engineer here. It's very good. So
Sure, thanks
so I will join.
for joining. And yeah, definitely this course will help you make a move. Any help needed, any sort of help, let me know.
Sure, sure. Thank you so much.
Welcome. So as this is a day 1 class and a bit of intro, I think we'll wind up here for today. And any further questions, you can raise your hand, we can discuss. If there were no questions, we can wrap up here for today. Anything else from anyone? Okay, so tomorrow we'll get started with our Git. So be prepared, get ready with your LMS access and get ready for the hands-on from tomorrow. All right then. Good day. Bye everyone. Have a great day. Thank you all for joining.